Hi everyone, welcome to Pi Academy. Today we're going to be doing the 2025 AMC10A Problem 3. So, how many isosceles triangles are there with positive area whose side lengths are all positive integers and whose longest side has length 2025? Well, the way we're going to be doing it today is all based on the triangle inequality theorem. Well, what is that? So let's take any random triangle. Let's draw one right here. Any random triangle. Say let's have this side be A, this side be B, and this side be C. Well, the triangle inequality theorem tells us that the sum of the sides A plus B must be greater than C, and likewise B plus C has to be greater than A, and C plus A has to be greater than B. Well, this helps us a lot with this question. So let's keep this in mind. So we have an isosceles triangle. That means two of the sides of the triangle must be the same. Well, how does that really help us? We have two cases in this problem. Let's have this be case 1. Case 1 is where these two sides are equal, and this side down here is 2025. Well, how many cases would this work? Well, we know if this length is 2025 over 2, then the sum of these two sides are 2025. But that isn't greater than 2025, and we know all side lengths have to be integers. So what's the next integer that can satisfy our triangle inequality here? That'd be 1013, which is actually one greater, or it's the ceiling function of 2025 over 2, if you know what that is. Well, let's double check if this works. Well, 1013 plus 1013 is greater than 2025, and these two are greater than that, and these two are greater than this. And we know this is the smallest value that would work. That's an integer because 1012 plus 1012 is 2024, and that's less than 2025. So we know that wouldn't work. Now, what's the largest number that would work here? Well, you could say it goes on to infinity, but keep in mind here it says the longest side length is 2025. So the longest is 2025. Because if we have this be 2026, then the longest side wouldn't be 2025 anymore. So this is the number range for that side length. And how many numbers are here? Well, because it's inclusive, we take 2025 minus 1013 plus 1, which is just 1013. But hold on, there's one other case. Let's take case 2 down here. Case 2 is if we have a triangle, an isosceles triangle, but instead of 2025 being the other side, we have the two equal sides both be 2025. Well, using our triangle inequality theorem, the minimum for this length down here would be 1. Well, I mean 1 plus 2025 is greater than 2025, and so it works. And the largest value, again, would be 2025, because it can't be larger than that, or else it wouldn't be the longest side length anymore. Wait, this has 2025 numbers in it, but we overcounted. If we take the equilateral triangle, and equilateral triangles is a triangle where all side lengths are the same. If we have the equilateral triangle 2025, 2025, and 2025, we overcounted it. We counted it in case 1 and case 2. So let's minus 1, so we have 2024 cases here. And let's take the sum of these two to find the total number of ways, which would be 3037. And this would lead us to get answer choice D.